Welcome to online session number 34 on shaping processes for polymer matrix composites, that is hand layup process, spray up process, filament winding process, resin transfer molding process, and the pultration process by S.B. Patil, Assistant Professor in Mechanical Engineering Department of Jeevantrao Sawant College of Engineering, Hadapsar, Pune. So we are discussing the course outcome number 6, that is to understand the principle of manufacturing of fiber reinforced composites and metal matrix composites, and suggest the polymer matrix composite and nano composite in automotive components in EVs, that is electric vehicles. So unit number 6 that we are discussing is the manufacturing of composites. So here today we are going to see the shaping processes for polymer matrix composites. So let us see this in detail, the shaping processes of polymer matrix composites. So PMC, that is polymer matrix composite, is a composite material consisting of a polymer embedded with reinforcing phase, and that reinforcing phase may be fibers or powders. Okay, so especially these are the fiber reinforced polymers, or we call it as a FRPs. So in popular usage, the PMC generally refers to fiber reinforced polymers. The FRP composites, FRP means fiber reinforced polymers. So this FRP composites can be designed with very high strength to weight and stiffness to weight ratios. And these features make them attractive in aircraft, cars, trucks, boats, and sports equipment. So this FRP composite shaping process can be divided into 5 categories. So first category is open mold process. Second one is closed mold process, filament winding process, pultration process, and other processes. So you can see here the FRP shaping process is divided into the process for continuous fiber and processes for short fiber PMCs. Okay, so these are the processes for continuous fiber PMCs, that is the open mold process, closed mold process, filament winding, filtration, and others. Others means the tube rolling process. And the processes for short fiber PMCs, that is open mold processes, closed mold processes, and other. Okay, again in open mold processes, it is divided into hand layup, automated tape laying, closed mold processes, compression molding, resin transfer molding. Okay, other means tube rolling. Again, here in short fiber processes, open mold process is spray up process, close means compression, transfer, injection molding, and others are centrifugal and continuous laminating. Okay, so let us see this video which shows the diversified application of this polymer matrix composites. So in this video, you can see these kinds of processes that we have shown here. So you can identify or you can imagine that this windmill is made up of which kind of the process. Okay, so that you can try to correlate with this video and this all these kinds of the processes. We are going to see all these processes in detail. So here you can see the different how the different fibers are arranged into each other. So if you can compare here, you can see here the specific tensile strength in kilonewton meter per kg. So for stainless steel, for titanium alloy, for aluminum, and for this carbon epoxy composite. Moving to the next slide, there is a quick session for you that write the application and products of the polymer matrix composites. Okay, so quickly join this link and try to give answers. We are not having much time. The link is given in the chat box. Just join and write down the applications or products of polymer matrix composites. Automotive applications, okay, sports equipments, automobile. Try to remember from the video the different kinds of the applications of or products of polymer matrix composites. Medical equipments, MRI scanner, okay, C scanners, surgical target tools, aircraft and aerospace, X-ray couches, okay, wheelchairs, windmill propeller, mammography plates, table, okay. Okay, so now we quickly move to the next session. So we'll see the different shaping processes in detail for the polymer matrix from composites. The first one is the hand layup process. So hand layup is the oldest open mold method for FRP laminates, that is fiber reinforced plastic laminates, dating to the 1940s when it was first used to fabricate boat hulls. Okay, so it is also the most labor intensive method. So as the name suggests, the hand layup is a shaping method in which successive layers of resin and reinforcement. Okay, both the layers of resin and the reinforcement are manually applied to an open mold to build the laminated FRP composite structure. So basic procedure consists of 5 steps that we'll see in figure. But the basic is that this is the hand layer process. So whatever layers of resins and the reinforcement are added one above the other. Okay, it's the successive layers. That is application of this resin and reinforcement one above the other to an open mold. Okay, to build the laminated FRP composite structures. The finished molding must usually be trimmed with a power saw to size the outside edges. So trimming process required for finishing, and the same 5 steps are required for all the open mold processes. Difference between the methods occur in step 3 and step 4. So we'll see the figure so that then we'll get clear. So this is a figure of hand layup procedure. So number 1, that is the mold is cleaned and treated with mold release agent. So this is the shape of the mold which is going to be clean now. Okay. Second, a thin gel coat, that is resin possibly pigmented to color, or coating, or you can say the application of resin is applied, which will become the outside surface of the molding. So here the coating is done. Okay. Number 3, when the gel coat has partially set, the successive layers of resin and fiber are applied. So here the application of resins and application of fibers. So first it is a cleaning, then application of coating, and then application of the fibers and resin one above the other. The successive layers, okay, are applied, and the fiber being in form of mat or cloth. Each layer is rolled to fully impregnated the fiber with the resin and remove air bubbles, and then it is getting rolled to remove the air bubbles. Okay, in number 4, that is the part is cured, that is heating process done here, and the fully hardened part is removed from the mold. This is this step number 5, that is finished part ready for trimming. So here in this process, what is required is the mold first thing. So this mold is required. So we can say this mold will gives us the output of the polymer matrix composite. So we are getting such a kind of output for the finished part. Okay, so first it is getting clean, then getting coated, then the layers of fibers and resin are applied successively by hand, then it is heated and cooled, that is curing part, and then last it is taken out. Okay, so let us quickly see this video regarding the hand layup process. So here you can see that the application of the fiber and the application of resin is done onto that mold by hand. Moving to the next slide, spray up process. So this represents an attempt to mechanize the application of resin fiber layers and reduce the time for hand layup process. So you can say that this is an alternative for step 3 in hand layup process. Okay, so here in the hand layup process, the resins and fibers are successively or added one above the other using hand. So here instead of uh, using hand, we can use the spray guns to mechanize the application or for the speed or for the production process. So in the spray up method, the liquid resin and the chopped fibers are sprayed onto an open mold to build successive FRP laminates. The spray gun is equipped with a chopper mechanism that feeds in continuous filament rovings and cuts them into fibers of length 25 to 75 mm, that is 1 to 3 inch, that are added to the resin stream as to it exits the nozzle. Okay, so this is the specifications required for the spray gun. The mixing action results in a random orientation of the fibers in the layer. So unlike hand layup, in which filaments can be oriented if desired. Okay, so in the hand layer, we can orient the filaments as we require, but in the spray gun, it is randomly orientation. Okay, so another difference is that the fiber content in spray up is limited to about 35% compared to the maximum of 65% in hand layer process. So this is shortcoming of the spraying and the mixing process. So one of the difference we can say between the hand layup and spray layup process is that in a hand layup process, we can manage the orientation of the filament or orientation of the fibers. Okay, also we can manage for the continuous fibers. But here in spray up, we require discontinuous for chopped fibers. Also, their orientation is random. The spraying can be accomplished by manually using a portable spray gun or an automated machine in which path of the spray gun is pre-programmed or computer controlled. Okay. The products made by the spray up method include boat hulls, bathtubs, shower stalls, automobile, truck body parts, recreational vehicle components, furniture, large structural panels, and containers. Okay. So this is the figure of the spray up method, that resin spray and chop fibers. Okay, continuous rowing, and it is getting chopping mechanism. So these are getting chopped here along with this liquid resin. Okay, so resin and the chopped fibers are sprayed onto this coat by some mechanisms. Okay, or by using the spray machine. So that's why the name of the process is spray up method. So let us see quickly see the video of the spray up method. So here you can see there are two different pipes. From one, the chop fibers are coming, and from other, the resin, liquid resin is coming, and it is going to spray onto that, and it is going to spray onto that mold, which is already being coated. So moving to the next slide, that is the filament winding process. Filament winding is a process in which resin impregnated continuous fibers. Okay, now let us see here. The fibers are continuous and they are impregnated in a resin. Okay, so it means resin is going to stick onto that continuous fibers, or we can say the resin is going to, sorry, the continuous fibers are going to dip into the liquid resins, and this resin impregnated continuous fibers are wrapped around a rotating mandrel that has the internal shape of the desired FRP product, that is the fiber reinforced polymer product. The resin is subsequently cured and the mandrel is removed. Hollow axisymmetric components, usually circular in cross section, are produced by this filament winding process, as well as some irregular shapes. Most common form of process that we'll see in the figure. Okay, a band of fiber rovings is pulled through a resin bath immediately before being wound in a helical pattern onto a cylindrical mandrel. Okay, so fibers are rove, okay, and then pulled through resin immediately and then being wound in a helical pattern onto cylindrical mandrel. Okay, and the continuation of winding pattern finally completes surface layer of one filament thickness on the mandrel, and the operation is repeated to form additional layers, each having a crisscross pattern with the previous until the desired part thickness has been obtained. So it means there is a one cylindrical mandrel onto which these continuous fibers, which are already dipped in a resin, are woven onto that cylindrical mandrel in a one pattern, say from left to right and right to left. So in a one left to right or right to left or one succession, it will create a one filament thickness, or you can say one layer. Okay, and if you want the more layers, you can go for the repetition of the process to get the additional layers. And after getting additional layers, the desired part must have some amount of thickness. So you can see here in this process, the filament winding process. This is the continuous roving through these pulleys. Okay. Then this is the resin bath where these fibers, continuous fibers, are going to dip here in a resin bath, and then it is going to pass onto this cylindrical or rotating mandrel in a one fashion. Okay, so once it is getting completed from, say, from this first point to last point, and to last point to say again first point, once it is one layer is completed, so to get the another layer we have to apply the same winding process for that particular time, so that we get the another layer, then number 3, number 4. So such a number of layers you can get on this rotating mandrel to get the desired thickness of that particular hollow polymer matrix composite. So let us quickly see the videos regarding this filament winding process. and these are the finished products. Let us see another video, the elbow filament winding process. Here we have seen the process for cylindrical mandrel, and here you can see for elbow shape. Okay, now moving to the next slide, the filament winding. There are several methods by which the fibers can be impregnated with resin. One is the wet winding, in which filament is pulled through the liquid resin just before winding. Pre-peg winding, also called dry winding, in which filaments pre-impregnated with the partially cured resin are wrapped around a heated mandrel. Or post-impregnation, in which filaments are wound onto a mandrel and then impregnated with resin by brushing or other techniques. Okay, so here these three methods are nothing but how the filament can be impregnated with the resin, or how fibers can be impregnated with resin, either by either before, that is a wet winding, or dry winding, or after filament windings. So two basic winding patterns are generally used, helical and the polar. You'll see that in figure. In helical winding, filament band is applied in a spiral pattern around the mandrel at helix angle U. And in polar winding, filament is wrapped around the long axis of the mandrel, that we'll see in figure. And after each longitudinal revolution, the mandrel is indexed or partially rotated by one bandwidth, so that hollow enclosed shape is gradually created. So you can see here the two basic winding patterns of filament winding. One here is this, that is the helical winding, and other one here is the polar winding along the axis of this cylinder. Next type is the resin transfer molding. So in conventional transfer molding, a charge of thermosetting resin is placed in a pot or a chamber, it's heated and squeezed by ram action into one or more mold cavities, and the mold is heated to cure the resin. The name of the process derived from the fact that the fluid polymer is transferred from pot into the mold. Okay, so here resin transfer molding, the meaning of it is that the heating of the thermosetting resin is done in another pot, and then it is transferred to molding process. So that is the name, resin transfer molding. So it can be used to mold tensile TS resins, okay, in which the fillers include short fibers to produce FRP composite parts, that is fiber reinforced composites. Another form of transfer molding for PMC is called resin transfer molding, that is RTM. So it refers to closed mold process perform in which preformed mat is placed in the lower mold section. Mold is closed and the thermosetting resin, that is polyester resin, is transferred into the cavity under moderate pressure to impregnate the preform. So basically this transfer molding process is similar that we have seen in the uh, last unit, that is the processing of polymers. Okay, here the only thing that the resin is getting compressed, is getting heated, cured in another pot, and then it is transferred to the mold. So several enhancement of the basic RTM process have been developed. One enhancement called advanced RTM that uses high strength polymers such as epoxy resins and continuous fiber reinforcement instead of mats. So application include aerospace components, missile fins, and snow skis. Two additional processes are thermal expansion resin transfer molding and the ultimately reinforced thermoset resin injection. Then in thermal expansion resin transfer molding, that is TRTM, is a patented process of TRTM incorporation that consists of these following steps. A rigid polymer foam, that is polyurethane, is shaped in a preform. So preform is nothing but the input material. Okay, so the preform is enclosed in a fabric reinforcement and placed in a closed mold. Then a thermosetting resin, especially the epoxy resin, is injected. Okay, is injected into the mold to impregnate the fabric and surround the foam. And last process, the mold is heated to expand the foam, fill the mold cavity, and cure the resin. So let's see the video for this resin transfer molding process. So this is the injection of the polymer matrix and the heating process. Okay, so this we called it as a preform here. This part which is form here, it is called as a preform, which is getting heated and injected with the polymer. Okay, so let us see this again. So here this preform is getting heated along with the injection of this polymer, and at the same time it is getting compressed. So this is the complete process for the resin transfer molding. So only the thing here is the first there is the putting of this specimen here, then injection of the molding, then you can see the heating. Okay, after heating getting completed, it is getting pressurized, that a compression takes place, then pressure is released, temperature is also released, or you can say it is getting cooled, and then the specimen is taken out. Okay, so moving to the next slide, that is the pultration process. So pultration is a process in which continuous fiber rovings, okay, continuous fiber rovings are dipped into a resin bath and then pulled through a shaping die where the impregnated resin cures. So you can say that this is basically a drawing process. Okay, so drawing process of the continuous fiber, drawing process for that particular continuous fiber which is already dipped in a resin bath. Okay, so initially the fiber which is continuous is dipped in a resin, and this fiber which is impregnated in a resin is pulled through a die, that is shaping die, where the impregnated resin gets getting cured. Okay, so there are three stages. You can say the one stage is the dipping of these fibers into the resin. Second stage is pulling that resin impregnated fiber, and third is the shaping of that impregnated resin, or you can say the resin impregnated fiber, and fourth is the curing, that is the heating and cooling, and fifth the you can say that the particular part is taken out. Okay, so first process again I repeat is the dipping of say continuous fiber in a resin. Then that resin impregnated fiber is getting pulled, then it is getting shaped, and then it is getting cured, and then it is getting taken out. Okay, the setup is sketched in the figure. We'll see that figure later. So which shows the cure product being cut into long straight sections. Sections are reinforced throughout their length by continuous fibers. So like extrusion process, the pieces have a constant cross section whose profile is determined by the shape of the die opening. Okay, so this is like a extrusion process, but we cannot say it extrusion because in extrusion, the input material is getting pushed through the die opening. Okay, and in a drawing, the input material is pulled through the die opening. So that is the difference between extrusion and the drawing process. So we can call it as a drawing process for the polymer matrix composite. Okay, so this process consists of 5 steps that we'll see the in sketches also performed in a continuous sequence. So first one is the filament feeding, in which fibers are unreeled from a creel, that is shelves with screws that hold filament bobbins. Okay, or you can say the feeding of the initial continuous fiber, that is feeding of the filaments. Then impregnation, that is resin getting impregnated, in which fibers are dipped in a uncured liquid resin. Then pre-die forming, that is collection of filament is gradually shaped into approximate cross section desired. And next is the shaping and curing, in which impregnated fibers are pulled through the heated die, whose length is 1 to 1.5 meter or 3 to 5 feet, and whose inside surfaces are highly polished. And then pulling and cutting, the pulling are used to draw the cure length through the die, after which it is cut by cut-off wheel with SiC, that is silicon carbide or diamond grits. So here you can see the pultration process. So this, okay. So here this first process, that is the winding process through these bobbins. These are different bobbins, and through the bobbins it is getting winded onto here, and then it is getting dipped in this resin bath, and then they are going to pass. Okay. So directly moving to the die, there is a one process that is pre-die former. So it goes through that pre-die former, then for actual die. Okay, then to the pull rollers, and then the extra length or the section is getting cut by using this saw. Okay, and here you can say this is uncured resin in the resin bath, which is not being heated. Okay, it is getting preheated in this pre-die former. Okay, and it is getting heated in this die. So why preheating or pre-die former is required? To avoid the delta T, or to avoid the change in a temperature. So suppose here it is a room temperature, okay, and here it is say 400 degrees Celsius temperature. So we cannot pass this room temperature directly into this say 400 degrees Celsius temperature. We have to preheat it, so to avoid the thermal cracks. Okay, so that thermal cracks or other dis can be other things can be avoided here in pre-die former. Also, the shape is close to the die in a pre-die former to get the accurate dimensions. So here we get the dimensions correctly, and then it through these pull rollers, it is these particular fibers are getting pulled in this direction, and it is getting cut according to what section we required using this saw. So the common resins used in pultration are unsaturated polyesters, epoxies, silicones, or thermosetting polymers. There are difficulties in processing with epoxy polymers because of sticking on the die surface. Thermoplastics have been studied for possible applications. E-glass is by far the most widely used reinforcing material, ranging from 30 to 70%. modulus of elasticity, tensile strength increase with reinforcement content. Okay, as we increase the reinforcement, its elasticity modulus and tensile strength is going to increase. Products made by pultration are solid rods, tubings, long and flat sheets, structural sections, tool handles, high voltage work, and third rail covers for subways. Okay, so let us see these two videos quickly. So this is the pultration process. Starting from that bobbins which is woven and getting passed through that liquid resin, then through the pre-dry former you can say to get the correct profile. So this one is you can say the die actual pre-dye former process. Then it is hitting in this die. And using the saw, the sections are being cut. These are the final products of the pultration process. Okay, let us see another video of pultration process quickly. So you can see here the continuous process, continuous winding through these bobbins. Okay, here you can see it is continuously passing, and this is the you can say the arrangement for the resins. So resin is passed here continuously. And here the actual process is carrying out. That is pressing and the heating process. And at the last you can see the cutting of the, so here you can see the cutting into the particular section. Okay, so quickly move to our last session, that is this quiz. I'm putting this link here, the same link and same code. So I request you to join the quiz immediately so that we can start it. So once this number goes beyond say 15 numbers, uh, we'll start the quiz immediately. Okay, so we are starting the quiz now. Dash dash layup is a shaping method in which successive layers of resin and reinforcement are manually applied to an open mold. So it is manually applied. You read the correct sentence to build the laminated FRP composite structure. Dash dash layup is a shaping method in which successive layers of resin and reinforcement are manually applied to an open mold to build the laminated FRP composite structure. So what is the answer? The answer is the let, let the time reduce. The answer is the hand. Okay, answer is the hand layer process. Next question is a process in which resin impregnated continuous fibers are wrapped around a rotating mandrel. Okay, are wrapped around a rotating mandrel that is the internal shape of the desired FRP product. Okay, so we have to see these words that they are wrapped around the rotating mandrel. Yes, it is the filament winding process. Okay, next question. In conventional transfer molding, a charge of dash dash resin is placed in a pot or a chamber. Which kind of resin, thermosetting or thermoplastic in transfer molding? It is asked in a transfer molding, the charge of thermosetting or thermoplastic resin is placed in a pot or chamber. And then for the next process. So let us see the answer. So it is correct. It is a thermosetting resin. And last is the dash dash is a process in which container fiber are dipped into resin bath and pulled. Okay, dipped and pulled. So by one word you can guess the answer. Yes, as it is pulled, it means it is the pultration process. Okay. So Ranjit, Balaji, Pranita, Aditya, and Abhishek. These students give the correct answers in a very short time. Let me see the others also. So others also have given the correct answers. Okay. Some gives 3 out of 4, 2 out of 4. So thank you for the today's session. Let me stop the recording now.